Hi kiddos, so welcome to another amazing installment of chemistry, or AP chemistry in this case. So these PowerPoints are actually from the 11th edition. I believe we have the 12th edition, but same thing. Anyway, so this unit or this chapter, we're going to go ahead and start off with chapter 5. Now, just as a recap of last semester, pretty much we went over all of the basic foundational stuff. And we did a basic review of stoichiometry, and we pretty much went over all of the different types of chemical reactions and how those chemical reactions play out whenever they're happening under aqueous conditions or basically in water. So for this chapter, we'll be focusing on thermochemistry, which I think is actually one of like the more cooler parts of chemistry. So thermo. Okay, hopefully that rings up kind of like a bell. Like, what does thermo mean? So hopefully you're thinking, and hopefully you think, oh, thermo, that means heat. So basically, what we're going to be studying for this one is heat chemistry. Now, the objective for this lesson is basically we're going to be laying down the foundation for this chapter. So at the end of this lesson, what you should be able to do, and what you will do, is you'll be able to explain that molecules have energy, and you'll be able to define terms used in thermochemistry through the use of a word map. Or basically think of it like a concept map. Now, first and foremost, what you need to know is energy. And energy is the ability for an object to do work or to transfer heat. So there's two ways that we look at energy. The first way is something called work. And the way that you do that, or the way that we look at it, is you're using energy from one object to move another object. So for example, if you were to go ahead and pick up a book, that's an example of you doing work. Now, another way of looking at energy is to talk about it in terms of heat. And that's so I'm still sick, so bear with me. 1 second. Hopefully I can edit this out, but if I don't, sorry. Okay. So, moving on. Heat is whenever you use energy to change the temperature of something. So for example, if you were to take a cup of water and add some ice in there, basically what you're doing is you're using the energy from both of those objects to change the temperature of them. That way you're cooling off your water, and you're also basically heating up your ice cube, and then eventually they reach thermal equilibrium, and so you've cooled off your object. Now, back to this one. Basically, what you need to think of for these is they're both ways for you to transfer energy from one substance to another substance. And we'll go more in depth with those. So there are two basic types of energy. First one is potential energy. And what potential energy is the energy of an object basically based on its position. So for example, this person right here, she's at the top of the hill. So because of that, she actually has the potential to actually like roll down the hill and actually use that energy. So it's kind of like stored energy, right? She's like getting ready to go down that hill. So molecules also have potential energy. So again, think of potential energy as based on the position of an object, or in this case, it's going to be a molecule. So here's a water molecule. Now, this water molecule also has potential energy because the position between the hydrogens and the oxygens, that actually causes some potential energy because of where they're located. All right, so another thing that you need to know is what the formula for potential energy is. Those of you who took physics, this will be a review. Those of you who have not taken physics, you will be learning this in about a week. So potential energy is equal to the mass of an object times the gravity times its height. Now the units for mass, again the SI units, which are the standard units, we always use are in kilograms. Now, gravity is always 9.8 meters per second squared, and height, because it has to do with like distance, that's measured in meters. Therefore, if you plug in these units, the units for potential energy are kilograms times meters squared over seconds. Now, the next type of energy is kinetic energy. And kinetic energy is basically energy in motion. So, for example, here, because she's basically moving down the hill and she's in motion, that also has to do with, that's going to be an example of kinetic energy. Molecules, same thing, they also have kinetic energy because even though we like draw them like they're just like the HOH, which is the water molecule I just showed you guys, we draw them as just kind of being flat and we think of them as just like, just sitting around. That's actually not the case. Molecules are constantly moving. So like in the air right now, like you're actually being bombarded by all of these nitrogen and oxygen and carbon dioxide molecules, everything that's in the air. So again, molecules also have kinetic energy due to their movement. Now, kinetic energy, the formula for it is equal to 1/2 mass times the velocity, where the units for mass are in kilograms and velocity are in meters per second. So if you plug that in and you square them, you'll end up with the same units as potential energy, kilograms times meters squared over seconds squared. Now, the cool thing about that is that there's actually a special name for them. Kind of remember like how newtons are equal to kilograms times meters per second squared. So anytime that you see kilograms times meters squared over seconds squared, that's actually equal to a joule, and the symbol we use is J. Now, ignore the bottom part, it just didn't come out right, but basically, there's another unit that people use to talk about energy, and that is calories. Now, 1 calorie is equal to 4.184 joules. That's really important for you to know because you're going to have to be able to make those conversions for some of the equations that we're going to be using. And I also wanted to clarify that this calorie is different from a nutritional calorie, which is what this bottom part is. So if you see 1 capital C calorie, that's actually equal to 1,000 calories. And 1 nutritional calorie, which is this capital C calorie again, is equal to 4.184 kilojoules because, again, 1,000 use the prefix kilo, and that's kind of how you get that one. Okay. Next thing we're going to talk about is system and surroundings. So what you need to know is that a system includes all of the molecules or whatever things you are studying. So in this case, it's going to be the hydrogen and the oxygen molecules. Okay, so where the red ones are the oxygen molecules and the white ones are the hydrogen molecules. So that's your system. That's what we're looking at. That's what we're trying to study in this. This is actually called a calorimeter. It's a special device that scientists use to actually measure changes in energy or heat energy. Now, the other part of this is if there's a system, right, which is what you're studying, everything else around it, that's called a surrounding. So in this case, that's going to be the cylinder and the piston, which is this thing right here. Okay, so again, system, whatever it is that you're studying, surroundings is everything else that's around it. So we're going to go back to work. So energy that is used to move an object over some distance, that again is called work. And the formula for work is equal to the force of an object times the distance over which that force is exerted. Now, over here we have a picture of a tennis ball and a tennis racket. So for this one, the tennis ball is what we're trying to study. And this is actually an example of work being done on the system by the surroundings. So that means that because this racquetball is hitting the tennis ball, which is what we're studying, it means that the surroundings are acting upon, or it's basically is doing work to the system, which is this tennis ball, which is what we're studying. So again, racquetball, surroundings, because it's hitting the tennis ball, which is what we're studying, that's the system. Therefore, you have work done on the system by the surroundings. Now, the flip coin to that is whenever you have work done on the surroundings by the system. So over here, I'm studying these candles. And so because these candles are basically releasing energy out into the system, okay, I'm sorry, into the surroundings, which is like basically the air around it. Okay, that is an example of work being done on the surroundings by the system. So I'm studying the candles. I'm trying to figure out how much energy or light they're basically spreading out into the world. So that's an example of work that's being done on the surroundings by the system. All right. So next thing we're going to talk about is heat. And heat is energy that can also be transferred as heat, which is remember we're talking about first and foremost you can transfer it as work. The second one is transferring it as heat. And one thing for you guys to know is that heat is always going to flow from the warmer objects to the cooler objects. So over here, right, the reason why you add ice to your cup of soda is because the soda is really warm. And so if you add ice in, the ice has a very low temperature. So because of that, the heat from the cola or the soda is going to move into the ice molecules. Okay, so what that's going to do is it's going to go ahead and cool off the okay, let me back up, sorry. I'm trying to not cough and it's throwing me off. So back to this. So here's your soda, right? It's really warm. So because it has a higher temperature, the energy is going to flow from the the soda into the ice. Now because of that, that causes the ice to actually melt, and then that's kind of how you have that. They're going to keep doing that until basically it reaches thermal equilibrium, and they're both the same energy. Now lastly, you need to know what the signs are. So what we use, let me go back over here. So for Q, Q is a symbol that we use for heat. Delta E is the change in energy. W is the work. And then we're also going to talk about the signs that they have. So don't worry too much about this part. It's actually not the slide that I want, but well, we're pretty much into this video. Anywho, I'm not sure if I'm going to play this for you guys tomorrow. That way I can actually save my voice. But this video is available to you guys regardless. Alright. Thank you guys for listening. If you have any questions, this would probably be the time to ask me or email me or whichever one. Anywho, thank you guys. Have a good day. Bye.